Last time I showed how we can control RGB for WS2815 12-volt addressable RGB LEDs from a Lighting Node Pro. It was all very duct tape and baling wire kind of hacked together, but it proved the concept, and I did promise I'd be back with a better implementation. In another previous episode, I showed you how you can use an SP901E to run lots and lots and lots of LEDs from a single Lighting Node Pro. You can probably see where this is going. Take a Lighting Node Pro, add an SP901E, some 12-volt power, a 5-volt buck converter, some 3D printed LED channels, and about 400 or so 12-volt LEDs, and I'll be adding lighting to shelves in my office. Now, I've had 5-volt strips there for quite some time, but I was never really happy with how they looked. So I've always been wanting to do something better with that. And the 12-volt LEDs turned out to be just the thing for the job. So I'm going to show you how I did all that. So a quick review of all the pieces that we have here. First, for signal and power distribution, I've got an SP901E here, and I'll be putting it in a custom box that I 3D printed and designed. Basically cutouts for the connectors, so it can be completely enclosed. I've got a lid for it as well. Each output uses 4-pin Molex SL. So this is just like the Corsair fans. It'll be using the exact same connector because I've got a ton of those laying around. And then using a Lighting Node Pro to generate the RGB signal. This will be connected to PC via USB, of course. And now, next, the Lighting Node Pro's output channels. I've got this cable right here that will take the two output channels and connect them to data 1 and data 2, respectively, on the SP901E. So we've got both channels on each of the output headers. The data and the data backup are both going to be connected to data 1 and data 2. So this will give us a total of 8 output channels for each of LNP channel 1 and LNP channel 2. So the Lighting Node Pro is going to get its power from this little teeny buck converter. It sits in line and it will give up to about it's spec to 1.5 amps of power. That's going to be enough for our purposes. We're not going to be powering any LEDs off the Lighting Node Pro. So we only need power in here to run the microcontroller, and that's not enough. That's not very much. But we could feasibly power maybe up to 20 or 30 LEDs using this little buck converter. Because it's so small and in line, we can also use one of these as a 12-volt WS2815 to 5-volt WS2812B adapter, where you have the buck converter literally in line. I'll probably do one of those. I thought that would be pretty cool. The LEDs that we're using are going to be BTF lighting, WS2815 LEDs. Got these off of Amazon. You can also get them on Temu. You can get them on AliExpress. They're pretty easy to get. They are a little bit more expensive than the WS2812Bs, but it's not crazy expensive. These particular strips have 60 LEDs per meter, and I have 2 rolls of 5 meters each. Now, these are going to be installed in these custom 3D printed channels that I printed out here, and I'm going to mount them on the shelves in my office. So we'll see how that goes. Now, the white ones, I'm kind of hoping for this glowing effect so that it comes out all over. we'll see how that works and what that does. I'm kind of interested to see how that turns out. Each channel also has diffusion covers, again, 3D printed. And overall, each one is 6 feet long, or just under 2 meters. So I'll have maybe around 100 LEDs or so on each strip. When we're all done, I'll have to solder connectors. So again, using the Molex SL, I've got these all prepped and stripped, ready to be soldered onto the ends of the LEDs, which will eventually connect them back to the SP901E through the output channels here on the custom box. So putting everything together, start with mounting the power socket, getting all of the different wires prepped by splicing the output wires and putting them in place in the box for when we get everything mounted. Next, we'll go ahead and connect the input from the Lighting Node Pro to the SP901E, so that way we can send the signal to it. Connect the power to the SP901E. At the same connection, we'll have the 5-volt buck converter that provides power to our Lighting Node Pro. Then connect the outputs to the SP901E, make sure everything is tight and in place. And then before we actually put anything on it, let's go ahead and test the output voltages. Make sure that everything is correct before we put any load on there. Make sure that we don't have anything melting. Once that all looks good, mount the SP901E into the box and connect the Lighting Node Pro to power and USB. So everything's together. Let's take a look at what we have here. Of course, right here on the top is the Lighting Node Pro, the SATA power cable. I cut and modified this. That is going to our 5-volt buck converter, which is going to power. We have 12 volts coming in. So here we have the power in. The cable goes underneath the SP901E and gets connected here. Each one of the Lighting Node Pro channels is connected to data 1, data 2. So channel 1 is data 1, channel 2 is data 2, and then these are all connected up here so that each one of these is going to be, this will be channel 1, channel 2, channel 1, channel 2, channel 1, channel 2, channel 1, channel 2 across the 4 outputs. So we've got a total of 8 ports going out. So this is actually already connected to a bunch of strips. So let's see if this thing actually works. So now that we have everything all together, I've got my 4 strips connected to 4 outputs. Got the power connected. So all I need to do is switch it on and we'll see if this works. And okay, it looks like one of these might be a little bit iffy on the connection, but we are looking good. Yeah, everything is working. So what's next is to go ahead and take these strips. I'm going to install them into the channels. Once I do that, I will take them down to my office and go ahead and attach these to the shelves. And I get the feeling it's going to be really, really obnoxious. So we'll see. And here they are installed. You can see the white channels on the top of the shelves and how they glow compared to the black channels that are underneath. I kind of like that. I think that's pretty cool. The Corsair Sales logo box is using 5-volt LEDs, and that's using one of those little buck converters with an inline adapter. So I've been running these for a couple of weeks now, and I'm really happy with it overall. I'm especially pleased with how the white LED channels turned out and kind of the glow effect that they have. Yeah, that worked out, I thought, pretty well. Power usage is really good. Each strip of about 110 LEDs pulls about 1.1 amps. So we're working with a little under 5 amps here total for 400 plus LEDs. With 5-volt LEDs, we'd be looking at around 4 amps or so for each channel. So it's a lot less amperage that we're using. We also don't need to worry about power injection, which we'd have to worry about with the 5-volt LEDs. Overall, it's a much simpler implementation, and they're a lot brighter. So that I thought turned out really well. That said, there's a couple of things that I think could have been better or that I could have done differently. First, at least some vents for airflow, perhaps a small fan as well. Enclosed, the SP901 got a little warm after going all day. Now, leaving the top off helped quite a bit with this. So at least some vents. For some airflow, and perhaps even a small little 40 millimeter 12-volt fan in there to handle that airflow would help. Second, add an on-off switch to the box. Now, there's all kinds of cool things that you can do with these. A plain, just toggle switch to something that lights up, or even a switch with a safety cover. I started off with an inline switch, and that only supported 2 amps. So needless to say, I had to take that out of the picture because it couldn't handle the load. There's other inline ones, but really, I think it would be better to just put a switch on the box itself so that it's an all-in-one enclosed unit. Next, add a beefier buck converter in there. So that way I have enough power to, fully implement the 2 5-volt channels that I have on that Lighting Node Pro, and then expose them just like I exposed the 12-volt channels from the SP901E. The inline adapter that I made for the logo actually works pretty well, but it's only going to work for a few LEDs, and that's not going to scale. And to be honest, I still have a ton of 5-volt LEDs laying around, so why not use them, right? Because, one can never have too much RGB, right? Now, even with that small buck converter in there, I could have added a small strip inside the box with a white top for it to glow, which would be kind of cool too, especially if you use some of the high efficiency, low powered micro WS2815Bs that are out there. You could add that, maybe even put a design on the top, some kind of logo or something like that. So there's some interesting things that I could have done there. Maybe I'll do that at some point later. I don't know, but that might be something that you might want to do. We could also add support for input and output channels, so that way you could very easily use these and daisy chain several SP901Es together. Though, if I was going to do that, I'd probably just use a second Lighting Node Pro for additional SP901Es. Finally, the channels themselves. Now, they look fine, and I'm pretty happy with both the black and the white ones, especially the white ones, like I said. But putting them together didn't work quite the way that I thought it would. Now, I thought that I would just crazy glue all the pieces together. They did have some overlap on the horizontal axis, but they just didn't have support on that Z axis. And so that didn't work very well. Now, I was actually able to make it all work, to get everything in place and keep it all together. And once they're installed, it's all great and it's not an issue. But maybe putting something in there to strengthen them when you're putting them together and installing them, a bracket or clips of some kind perhaps, would make that go a little bit better. Now, I'll include links to all of the STLs below, so if you have a 3D printer and you want to do this, you certainly can. I'll also include the FreeCAD files, so that way you can go in, maybe do some mods yourself, see how it was put together, change things around, do whatever you want. As always, if you like this video, I'd appreciate a like below. If you want to see more stuff, hit that subscribe button. And until next time, may your temps be low and your RGBs be bright.